All right. So we're going to talk about law of sines today. Let's get started. All right, let's get started, guys. Law of sines. So a couple of reminders, just some piece of information before we actually get to the law of sines. We are with law of sines and law of cosines. We are talking about oblique triangles, and that means that we don't have any right angles. So we can't use SOHCAHTOA, we can't use our familiar trigonometry, but it does make an appearance. So we're looking at triangles that have no right angles, and we want to find out information about them. When we say that we are solving, when we want to solve a triangle, just as a reminder, solve means we want to find all the sides and all angles. And we're going to use law of sines for three different kinds of triangles. For triangles that have two angles, when we have two angles on the side. And we think back to geometry, we're talking about, for two angles on the side, we're talking about angle-angle side triangles or angle-side-angle triangles. So those are two of the types of triangles that we'll use the law of sines for. And once we see them, once we look at the law of sines and law of cosines, it's pretty clear which one you would use for a particular type of triangle. But we just so we know. And so today we're just going to type with these two kinds of triangles. Tomorrow we get into a little more interesting situation with two sides and an angle. And that would be an SSA triangle. And we end up with some different possibilities with a side-side angle triangle. Sometimes a triangle doesn't exist, sometimes two triangles exist, sometimes only one. So we have to figure that out. So we'll leave that for tomorrow. And then a reminder about how we label triangles when we draw them. We've been doing this all through chapter 4 and 5, but just as a reminder, we label the angles with capital letters, and then the sides with small letters opposite the angles. So that's how we're going to label our triangles. So now I think we have everything. We're ready to write down the law of sines. So what we're going to do today is I'll write down the law of sines. I'll show where it comes from. It's very easy idea where it comes from. And we're just going to do a couple of examples. Pretty short and sweet lesson today. And then we'll be done. So, questions before we go on? Okay. So the law of sines tells us that when we label our triangle the way we just did, that A over sine A equals B over, sine B, and that equals C over sine C. So we end up with three different equations here. And I could also do the reciprocals of these it doesn't matter how we write it. I can say sine A over A equals sine B over side B, and that's sine C over side C. These tell us the same thing. And I usually choose which way I want to write it, depending on whether I'm looking to find a side or an angle. Just makes solving the equation less steps if you write it one way versus the other, but it doesn't really matter. All right, so let's talk about why this works. Why does this come about? So here's our triangle that we just drew. Our oblique triangle with no right angles. And we want to find out some information about this triangle. Well, we know a lot about right triangles, so what we do is just like we've talked about on Fridays before we start classes, we're going to turn it into a problem that we already know how to solve. So I'm going to draw this height, this altitude, and I'm going to turn this into two right triangles. And I'm going to call that side H. Well, now I have two right triangles. We know how to deal with right triangles. We have SOHCAHTOA. So we can work with that. So I'm going to find H. So I'm going to say, using the triangle here on the left, I'm going to say that the sine of angle A is H over B, opposite over hypotenuse of this triangle. So this tells me that H equals B sine A. Now I'm going to look at this triangle on the right. On the triangle on the right, I can say that sine B equals H over A. And that tells me that H equals a sine B. These are two equivalent expressions for H. So I can combine them and say that B sine A equals A sine B, or A over sine A equals B over sine B. And then for the other sets of equations, I would just draw in my altitude to the other sides of the triangle and do the same thing that I just did here for the other sides and the other angles. Exact same process. And I would get the other equations. So to get the law of sines, we turn it into a problem we already knew how to solve using SOHCAHTOA. And then we have a new way of working with triangles that don't have any right angles in them. Kind of nice. And law of sines is very easy, not a complicated thing. The one thing that comes up when we're doing law of sines, law of cosines, that makes it a little more challenging is we will, in our application problems, we'll see some bearing problems. And I know that students usually love the problems that have to do with bearing. But other than that, the problems are pretty easy. So questions? Questions on law of sines? So let's look at a couple of examples of how we're going to use law of sines, and then we'll be done. Okay. So let's say we have a triangle, and we know that angle A is 123 degrees, angle B is 41 degrees, and side A is 10 inches. And we want to find side C. So this one isn't asking us to solve the triangle, we just want to find one side. What I always recommend that you do with these kinds of problems is draw a picture. Doesn't have to be a beautiful, perfect picture, but it just helps to visualize what we're talking about. There's 123 degrees. Doesn't matter which vertex I label with which angle, as long as I stay consistent. Side A is 10 inches, and there's B, and here is, whoops, that would be C. I already used B. So there's side C that I need to find. So this would be an example of an angle-angle side triangle. That's the configuration I have. That tells me I can use law of sines. So what do we need to do to find side C? What are we going to have to do? How are we going to proceed here? What do you think, man? So we have that relationship, so we can say that we know that we have the fraction or the ratio 10 over...
Wait, no, you want easy one was those two angles, so find angle C and then equal.
Okay, that's perfect. So we know that our three angles have to add up to 180 degrees in our triangle, so we can find angle C. Whenever we have two angles in our triangle, we can find the third one, because they all have to add up to 180. So add these two together, subtract from 180, and we get that equals 16 degrees. So we have this relationship, 10 over the sine of 123 degrees equals C over the sine of 16 degrees. So that's the equation that we would use in law of sines. And then we just cross multiply. And you could plug these numbers into your calculator here. I usually write it out before I calculate at the very end. So I would say that C equals 10 sine 16 over sine of 123. You don't have to write it out this way. You could calculate these and use the numbers here. And we get that side C is approximately 3.29 inches. So, pretty easy problem. Law of sines problem is usually pretty easy. Questions on that one? All right, let's look at another one. Let's say that we know that A is 95 degrees, C is 68 degrees, and the side between angle A and C is 115 units long. And we want to find the other two sides. So I recommend starting by drawing a picture. So I'll call this angle A, that's 95 degrees. Call this angle C, 68 degrees. And it says the side between A and C is 115 units. So that side is 115 units. So we need to find side C and side A. That's what the problem asks us to find. So here we have an angle-side angle triangle. So we know that we can use law of sines. So what are we going to need to do here? Find angle B. And then we're back to doing exactly like what we did in the last problem. So all of our angles have to add up to 180. So we can find angle B. We find that angle B is 17 degrees. And then now our setup is exactly like like what we had before. We just had to do one step here, finding the missing angle. So we can say that 115 over the sine of 17 degrees equals, we'll find side C here, equals C over sine 68 degrees. So C equals 115 sine 68 over sine of 17 degrees. Plug that in my calculator, and I get that that's about 364.69 units. And do the exact same process for A. I would get that A. I'll write out the process again. I'll use 115 and sine 17 degrees again. I could use side C and angle C for this one if I wanted, but since I already have this, I'll do that one again. And that's going to be A over sine 95 degrees. So A is 115 sine 95 degrees divided by sine 17, which gives me about 391.84. Law of sines problems end up being the same. You do a couple of things, and then you're doing this. Then you're doing the same process. So, any questions on that? Sometimes with law of sines problems, you end up solving for the sine of an angle. So what if I just want to just give you a reminder, what if we ended up with, in a problem, we ended up with something like the sine of A equals 0.685. We got that out of law of sines. How do we find angle A from there? Inverse sine. We take the inverse sine of A equals the inverse sine in your calculator of 0.685. So when you need to find an angle, you can use the inverse sine with law of sines. And one other reminder: when you're working with triangles, your angles are normally in degrees. So make sure your calculator's in degree mode, or you're going to have a rad time. Questions on law of sines? Tomorrow we'll talk about the side-side angle triangle, which we call the ambiguous case, and we will also talk about how we can use the law of sines to find the area of triangles. So we'll have another way of finding area of triangles, which is kind of nice. All right, homework. And problem number 42, I think, has bearing in it.